Hi everyone. So I wanted to show you a couple of things here of how you can begin to picture equipotential surfaces, that is regions of constant electric potential, as being analogous to topographical maps. So first of all, let me describe to you how a topographical map is constructed. Right here is a picture of a mountain, and then each individual orange outline that you see right there is separated by 250 feet in altitude. Think of each orange contour line as referred to as an equipotential surface. So for example, along the 2,000-foot line, you're always at the same height above sea level, that is 2,000 feet. At 2,250 feet above sea level, that's an equipotential surface, and then so on and so on and so on, as you eventually reach the top of the mountain. Okay, now think of each individual contour line here as an equipotential surface, and then therefore you can kind of think of them as slices. So let me show you a different picture, this one down here. So we have here, for example, the slices, these contour lines representing equipotential surfaces, that is all at the same height. So this portion here of the picture, all of this is at the same height. This portion of the picture here, all of this is at the same height, and so on and so on. All the individual equipotential surfaces here are separated by the same height, say like 10 feet. So start here, this is 10 feet higher, 20 feet higher, 30 feet higher, and so on. You can think of anything as being upwards in elevation as positive, and then over here in terms of the seabed, you can think of anything as downwards as negative. So right here is sea level, for example, and then we could say that this is 10 feet below sea level, 20 feet below sea level, 30 feet below sea level, and so on. Once again, each individual contour line here can be thought of as an equipotential surface, positive for upwards and negative for downwards. Okay, now by analogy, let me go ahead and show you equipotential surfaces here associated with a couple of different charge configurations. So this right here is just showing us a positive point charge like so at the center of the diagram, and then here in green are the individual electric field lines. And then you see here a series of concentric spheres. All of these concentric spheres are three-dimensional equipotential surfaces. So anywhere along the surface of this sphere, you can think of that as all being the same height. Similarly, for this sphere here, you can think of this as all being at the same height. And this is all rendered in 3 dimensions, for example. We could see that here as I rotate the applet around in this manner. Okay, now let me go ahead and show you a couple of other different charge configurations here with this applet. They only provide for us a couple of examples. So here's another example in showing us 2 positive charges, like so. And then you could see the equipotential surfaces here as these 3-dimensional shapes. And then you can see how it becomes 3-dimensional as I rotate it around in this manner. So each individual surface here is all at the same height, if you will. Each individual surface is an equipotential surface. Now for these red equipotential surfaces in this portion of the applet and the one that I showed you earlier, you can think of that as all being positive. Let me show you one that is positive and also negative for a dipole situation. That would be right here. So recall, first of all, the green shape of the dipole's electric field. That's what you can see here in the applet. But then we have equipotential surfaces here starting at the origin, which is right in the center of the diagram. Think of this right here as height 0. And then going towards the positive charges, like say 10 feet high, 20 feet high, 30 feet high, and so on. Once again, I'm using feet here as an analogy. But then you could also go downwards towards the negative charge, if you will. You could think of this right here as negative 10 feet, negative 20 feet, negative 30 feet, and so on. So this is like showing elevation on this side of the applet. This is showing depth here on this side of the applet. And then once again, you can rotate it around to see the equipotential surfaces here from different orientations. Okay.